So we're going to go even further on what we did previously. Can you predict the graph? So we've kind of done some hints about it, but there's some things that we need to make sure we know. So let's go like this. We know the zeros, -10. Oop, maybe I'll make that -7, -10, and 12. Okay? So we know it's going to cross here, here, and here. We know, let me zoom in a little bit more. We also know the y-intercept if I plug in 0, 0, 0. So it's 10 times 7 times -12 is a very big negative number. Okay? So we'll just say it's a very big negative number. We know there's 1x, 2x, 3x. So we know it's x cubed. Okay? So I want us to go back to the page that I started having you write down. Let's see if I can find it. Back here. Okay? I'm hoping you can find some trends, some things that are the same. And here's what I'm hoping you can see. I'm hoping that you can see, and I'm going to circle these in pink. And I want you to notice I'm circling those in pink. And I'm circling these in blue. And I want you to notice something about where they start, where they end, what kind of behavior they have. Okay? And what I'm hoping you can see is this is to the first power, to the third power, to the fifth power. Those are all odd. To the second power, to the fourth, to the sixth. Those are all even. If you'll notice, the end behavior is down here. Negative infinity, negative infinity, negative infinity. And then it goes up to positive infinity, positive infinity, positive infinity. Where if it's even, they're both positive infinity. Where if it's even, they're both up, positive infinity. If it's even, they're both up, positive infinity. So what is that telling us? Hopefully that tells us, and then if obviously, not obviously, but if it is negative, that means it's the opposite. Okay? So let's go back here and talk about those generalizations, and it will be easier to graph it. Now remember, I'm probably not going to give you a problem like this on the quizzes, on the quiz, because all you have to do is graph it and copy it off there. I'm probably going to give you a different type of question. So you want to make sure you're clear. So if it's to the odd power, then we know that the end behavior is negative, positive, where it starts from the bottom and works their way up. Okay? And then if it's x to the even, we know that the end behavior are both positive, which means it starts from the top. Okay? Now, I don't know about you, but sometimes that's kind of hard for me to remember, so I just focus everything on, let me go back, a line and a U. I am so good at making a line and a U. So if it's odd, I start by making a line, then I count. So if it was x to the 18th, I would go, okay, that reminds me of a U because it's even. So a U starts here, and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way to 18, and it would end up going up there. Well, if I have x to the 7th, I go, oh, okay, that's odd. That reminds me of x to the 1st. If I'm making a line, I start down here. 1, 2, 3, 4, 5, 6, 7. And if you look, it works out. Okay, so let's go back, and let's actually do this. So we have x cubed. X cubed reminds me of a line. Go through, go through, go through, done. Now, is this the perfect graph? No. Is it a sketch? Yes. I could have also graphed it like this. Let's see, there were 2 on the negative side. It could go like this. I don't know, I can't draw a graph very well, but you get the idea. It could also go, again, I'm not the best at drawing graphs, but you get the idea. Through, 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 through. And it's cubic. 1, 2, 3. It makes 3 lines. Okay, let's do the next one. All right, let's see. How many x's do we have happening here? We got a bunch. We got a -6. We have a -3. We have a 5, and we have an 8. 1, 2, 3, 4, x to the 4th power. So if it's even, it starts from the top, or for me, I think of a u, so I'm going to start up here. Oh, I have to figure out the y-intercept. 0, 0, 0, 0. So you know what I'm going to do, because we're not figuring out the exact y-intercept? This is a positive, that's a positive, that's a negative, and that's a negative. Positive times a positive is a positive, times a negative is a negative, times a negative is a positive. So the y-intercept will be somewhere up here. Okay? So 1, 2, 3, 4. 1, 2, 3, 4. That works out. I challenge you to try some of these on your own. Okay? And some of you go, well, you're doing them for us. Okay, well, you can pause it. In addition, you could just make up a problem and then put it in decimals after and see if it matches. Okay? So -4, -2, 6, 10, 1, 2, 3, 4. So it's x to the 4th. But the problem, so it's similar to this one. The problem is this time it's negative. So that means instead of starting from the top, I'm actually going to start from the bottom. Oh, and I need to figure out the y-intercept. So this is negative, positive, negative, negative, negative. Those two negatives make a positive, those two negatives make a positive, so my y-intercept is positive. 1, 2, wait a minute, something happened here. I must have messed up, hold on. Negative and negative, oops, I'm off. Okay, so I know it didn't work because when I started going like this, it would go through here, so I messed up. Negative, positive, positive, negative, negative. So those two negatives turn positive. That means y-intercept is negative. Okay, there we go. We go through, we go through. So this one and this one match. This is just that reflecting. Okay, which you can't see because I've got it off the screen. Okay, so now we're going to do this. -7 and 7. That's no problem. But how are things different? The squared. The squared means we're going to bounce. So before we're just like, go through, go through, go through. Now we're actually going to be bouncing. So what power is it? X squared, and x squared is x to the 4th. So it's x to the 4th, it's even, it stops. Oh, I've got to figure out the y-intercept. So a positive squared is positive, and a negative squared is positive. A positive times a positive is a positive. So it goes here. Okay, so I start from the top, as I did before. The problem is here I went through, but since it's squared, I bounce. Go through, what do I do when it's squared? Bounce. So notice the difference, the bouncing. Okay, let's do another one. -6, -3, 5, 8, 12. Do we have any bouncing? No. This is positive, positive, negative, negative, negative. Two negatives make a positive, so my y-intercept is negative. Okay, 1, 2, 3, 4, 5. X to the 5th power reminds me of a line. It starts down here. Go through, go through, go through, go through, go through. Negative behavior, positive behavior. So I feel like if I was doing this quiz, something I would say is, okay, create a function that would give me a negative n behavior and have a degree between 10 and 15. Okay? That would be a great question. All right, look back at your work from this, on a graph, the real roots. What is the maximum minimum number of roots a degree 3 can have? So if it's degree 3, there's different options. One option is like x minus 1, x minus 2, x plus 3. Okay? Let's make that up. So that would be 1, 2, -3. So it's x cubed, negative and negative and positive, negative and negative and positive. So it goes through, it goes through, it goes through. That's one option. Another option is I go x minus 1 squared, so that gives me 1, 2, and there's 3. This time I'm going to go a 1 and a -3. Here's my bounce. A negative squared turns positive times a positive is a positive. And I go through, but then what do I do at the 1? Bounce. Okay. Another option is I could do x minus 1 cubed. And that just means there's 1. If I cube a negative, it stays negative. So I could do something like this. Now, if it's cubed, it's not bouncing, but what it's doing is going through at that spot. I didn't do a very good job. Let's see. Probably should go through and then a bounce. I'm not very good at that, but you get the idea. Okay? All right. So let's see. Oh, yeah, and I guess I could do examples of imaginary roots. So I could have like x plus I, x minus I, and then x plus 3. So I could just have one real root, but I have to show the shape, so it bounces up there. So that's a really good question. I like these types of questions where you have to draw something and give an example of. Or I might draw a bunch and you say which ones match. These are really good questions. Okay, so I will star them so that I remember and you remember. Okay, the minimum degree, 1, 2, 3. As the x value increases, so this one would be negative infinity to positive infinity. That's what I want. Oops, you can't see that. Next one, minimum degree, 1, 2. Normally it would be positive infinity to positive infinity, so this is negative infinity to positive, but it went down, so they're both negative infinity. Okay. This one, 1, 2, 3, 4. Positive infinity, so positive infinity. And then this one over here, 1, 2, 3, 4, 5. So fifth power, that's positive infinity, and that's negative infinity. If I asked for the degree, this would be x cubed, positive. This would be negative x squared. This would be positive x to the fourth. And this would be negative x to the fifth. Okay? I love this page. This is a great page for me. Okay. All right. This one, they want you to see how these two are different. So let me pause it really quickly so that I can graph it. So what I just did on my phone, let me lower this a little bit, is I graphed this one. Oh, wait a minute. I can't see that. Let's go like that. Those two. I graphed those two, x minus 1, x minus 1. What is the same about them? What's different? So what is the same is they both have a root of 1. Okay? So what's the same is that they both have a root of 1. Both of them have a bounce. And even their y-intercept is the same. So also their y-intercept is the same. But what is different is the actual graph itself. If you look, they're very close, but if you look, this one is wider. This one maybe is a vertical compression, and this could be a vertical stretch, even though it doesn't quite look like that. But this is to the power of 4, and this is squared. Okay? So let me take those off now, and that's pretty much what I wanted you to get out of that question. Oops, let's see, something happened here. I think I deleted the wrong thing. Welcome to me. Okay, so what they want now is the difference between these two. So what's the same about them? They have the same shape. Ooh, and I should add to the differences over here is the shape is the same. Okay, so the shape on that is the same because they're both looking like that. Okay, even though it's to the fifth power, so there's probably some bounce somewhere. Okay, but then what's different are the roots. Here the root is 2. Here the root is -1. Okay, and I think the y-intercepts are different. Okay, so just comparing things, that's another good way to do these types of problems. I like it. All right, what effects does the squared factor? So what they're saying is, what does it mean when you see a squared? It means it's going to bounce. So if it has a cubic factor, it's no bounce. So we just want to look at the squared, or to the fourth power, to the sixth power. Okay, I just wanted you to get that. All right, so now it's saying you can use a number line to represent the x values. The bold parts of the line below show where the output of the function is positive. Okay, so if I have an x-axis, I think I'm going to wait till the next video on this one, actually.